Howdy folks, welcome back to another Out of Spec Renew video. Today we're going to be working on this 2015 Tesla Model S P85D. This car actually has an issue with the battery pack, so we're going to be dropping the battery pack out of it and opening it up to hopefully perform a successful repair on this thing. Obviously, whether or not the repairability of it is going to be viable is kind of going to depend on what we find when we open the pack up. But based on the data that I've seen so far on it, it looks like it should be a repairable issue. So let's dive right in. We'll take a look at what the issues are, and then we'll get right into the repair. All right, so like I mentioned there in the beginning, this is a 2015 Model S P85D. And let's go ahead and hop in real quick. I've got the car in service mode, actually service mode plus since I'm plugged in with Toolbox. But what we're going to do is we're going to go take a look at the service alerts here and show you what we've got going on. So we have a few things that are not super important. We've got, left shutter, radiator shutter, no feedback, a few things like that. But our biggest issues here are going to be these codes down here. So we've got a module brick mismatch. Of course, our stuff is moving all around there. Amp hours to be charged imbalance, SOC imbalance. But our big one that our main clue here is this BMS, both F107 and W107. W just means warning, F means failure, so they're both effectively the same code, just one is a warning code, one is a failure code. But essentially what that means is that we've got an inaccurate voltage measurement that usually indicates that either one of the wires that would connect the cell voltage sensing to the BMB on the module for voltage detection has either become disconnected, or there's a problem with the actual BMB board itself where it's getting an improper voltage measurement reading. So yeah, that's basically those issues there. What we can take a look at with Toolbox is, it didn't fully connect there, but our most useful thing actually to take a look at here is actually going to be scan my Tesla. So let me pull up my app for that here. And this will give us all of the voltage readings for every brick within the pack. So look at that. So we actually have proper voltage measurements here. But we do have a pretty significant imbalance between them. So what I'm guessing is that we probably do have one of those voltage measurement wires that connects to the brick probably is disconnected. But that it's making contact intermittently. So sometimes it's making contact and giving a good voltage reading, and sometimes it's not, so it probably has a really poor connection. I'm going to see... Oh, here we go. So we're finally connecting here. I'm going to see if we can clear that F107 fault and get the car to operate again. In which case that probably more or less kind of confirms my suspicion. So let's see, let's go, we want to go actions, we want to go BMS, and let's see, we want to clear this brick 6 substitution. Oh, except we're going to need our gateway unlocked, so yeah, it's gonna fail because the gateway is not locked, or the gateway is locked. So I'm going to go ahead and unlock the gateway real quick. We'll try this again. All right, so we're unlocking the gateway, which means drive rails on, right turn signal on, gateway unlocking, and unlocked. Okay, so we're good there. Now we can try to run this procedure again. There we go. So we successfully cleared brick 6 substitution. I don't think that that's really going to be applicable to this, but this open VSH latch is going to be the big one. Okay, so cleared latch bits. And we will re-enable pack contactors. Okay, so if we give the car a minute here, it may attempt to start. Well, it is still throwing VSH faults. Actually, we might need to clear another thing to get rid of that. Where's the U018? Well, there was a U018. At least I thought there was. Brick mismatch, amp SOC imbalance. Okay. We might need to try and clear another couple of things out here. Okay, well, I'll try and play around here and see if I can get this to do anything. We know for sure that there's an issue. I'm just not sure whether or not I can get the car to power back on. I may or may not be able to get that to happen, depending on whether or not it still thinks that there's an open VSH issue. But, I mean, based on the cell voltages that I'm seeing, it looks like we're okay. Let's see if I go to this one. So it looks like our low cell is going to be brick 3 on module 1, and everything else is all pretty close. Interesting. Okay, well, I'll play around here, see if I can get the contactors to close. Either way, we have to drop the pack to perform repairs on it, but I just want to see if we can get this to power up again. Alright, so I think that the reason why we can't get the car to re-enable the contactors and restart is that we do still have a brick voltage mismatch. So while we are getting a quote-unquote relatively normal voltage reading from the BMS, it's still off by a pretty significant margin. The connection is poor enough that the total voltage of the module does not match the sum of the voltages on all of the bricks within the module. So that's what this alert means. And because of that, it's still going to continue throwing this 107 alert, even if we try to clear it. Even though it's not fully disconnected, it's got a poor enough connection that it's not, the math isn't adding up for the voltages on the modules. So, with that said, I did, before this car actually showed up, I did perform a remote diagnosis with Toolbox on this car, and when I did, that same that same brick 3 that was the one that had the significant voltage imbalance, everything kind of shifted over here, but this same brick 3 that's significantly lower than the rest of the cells here, that one was indeed significantly lower than the rest. When I did the remote diagnosis and looked at the log data, it was down to whatever, maybe it was measuring half a volt or something crazy like that. So I'm guessing that we have a disconnected sense lead in here that's intermittently making contact with the collector plate on the module. So anyways, what we've got to do now is we've got to go ahead and drop the pack, get it opened up. We'll pull module 1 out to start, although ultimately we'll probably end up pulling the other modules out as well, just to see what we've got going on. I did want to see, I don't think Scan My Tesla will give me isolation resistance, will it? Yeah, I don't think so. But anyway, yeah. We'll go ahead and get this powered down. We'll get our high voltage system disconnected, which basically just means 12-volt battery and the high voltage interlock loop. And then we'll get ready to drop the pack out, which I've kind of already showed that in detail when I did the work on my Model S out there to do the pressure test on the pack. So I'm not going to go too into detail on dropping the pack. The main thing that I want to focus on with this video is actually doing the repairs on it. So if you want to see actual in-depth process on dropping the pack, you'll have to check out that other video. But anyways, without further ado, we'll go ahead and get working on this thing. Alright, as per usual, first step here is we're going to go ahead and disconnect our 12-volt battery and our first responder loop, or you could call it a service loop, whatever you want to say it is. Tesla officially calls it a first responder loop, but it always gets disconnected for service. But yeah, we'll just pop these off. Alright, now we can actually pull the front tub out, which is indeed attached, although these have been unplugged, so they did definitely have this out at some point. Got to peel our carpet flap back here, and let me grab my tools for this. So normally there's 2 nuts in here, but one of the studs is busted off, so we've only got one in this case. And then our wiring harness that would attach to the trunk button and stuff there just has a little grommet. We'll push that through and just push that wiring harness out. Swap to a 13. And up here at the top, we've got 2 bolts. I'm just going to put that nut right in there so it can stay with the front. We'll set this aside. And there we've got our 12-volt battery. So we'll just loosen that off. Okay. And then on this side over here, we've got our first responder loop. Sometimes you can pull this out enough that you can unplug it without having to remove cabin air cleaner assembly, but usually not. So I'll have to go ahead and remove that as well. So we'll pop out our actual cabin air filter, which looks like it probably could use replacement. Not our main concern right now, though. And then the other thing that I need is a long extension. Let me see if I can grab one of those real quick. Alright, so we've got 1 bolt on either side of our cabin air cleaner housing here. Try to make sure not to drop those into the abyss. And usually there's a couple clips on top of here that snap this thing in. Those have long since been broken on this car, so that makes it easy to pull that thing out. And now we can actually get to our service loop. So we'll just push the red tab out here. Dang, that's a tough one. I might need to get a screwdriver in there to kind of pry that apart a little bit. So usually on these you can just kind of push on the 2 tabs. Don't know if you can see that, but you can kind of push on these 2 tabs on the back side to get that to pop out. But this one's a little bit stuck. So instead we'll stick a flathead screwdriver in the front side of it and pry it up. So you just pull that red tab out and then that thing just disconnects. So we'll set that aside, and now we can lift the car up and start pulling the pack out. Alrighty folks, so as you can see, we've got the car up in the air here, ready to drop the pack out. Like I said before, I recently did a video where I actually pulled the pack out of my personal car, did a pressure test on it, checked for leaks and stuff, and I went pretty in-depth on the removal process for that. So I'm probably just going to time-lapse through this one. If you want to see a more detailed, sort of step-by-step of removing the pack, make sure to check out that other video. But basically, yeah, I'm just going to pull the pack out of this. Because this is a performance model, it does have the large drive unit in the rear, so before I pull the pack out, I'm actually going to remove this skid panel and remove the encoder sensor on the drive unit to check for coolant intrusion. I do that on any large drive unit equipped car that comes into my shop, just because I want to make sure that the customers can make an informed decision. If it looks like it's in pretty poor shape and the drive unit appears that it needs to be rebuilt, I'll probably let the customer know before I actually pull the pack out, because they may or may not want to actually spend the money to both rebuild the drive unit and repair the battery pack. So it's just one of those things where I want to make sure my customers are informed with what issues they have with the car so that they can properly make decisions about what they want to do with it. But yeah, with that being said, I'm going to go ahead and get started here, and hopefully the encoder sensor doesn't look too bad, and we'll proceed with getting the pack pulled out of this car. All right, well, it looks like the time lapse didn't actually work, but that's okay, you didn't miss too much. Got the pack out of the car with no drama. That came out basically no problem. I did check out the speed sensor on the drive unit, and there is indeed no coolant intrusion. This is actually a twice remanufactured drive unit. Probably can't see it up there without a light, but there's a sticker on the end of the rotor coolant manifold that indicates that this was rebuilt sometime in 2020. At least that's the last time it was remanufactured. This drive unit, the actual housing, is actually older than the rest of the car. This is a 2013, I think H would be August. Pretty sure that's August of 2013 build. This car was actually built in January of 2015, so the drive unit is older than the rest of the car. But anyways, we've got the pack out, so I'll go ahead and get it kind of rolled out from under the car here. We'll vacuum up all the dirt and stuff on here. We want to make sure not to get any dirt in our connection points here. In case you didn't know, one of the cool things about Legacy Model S and Model X is they use the Rapid Mate system, which basically allows the high voltage connectors on the car, as well as the data connectors, and the coolant connections over there on the other end to basically seamlessly connect and disconnect, because this car was originally designed with battery swapping in mind. So these are actually just spring-loaded, and they can move around a little bit if need be, and then they just get lined up in these and they self-connect and self-disconnect. So makes it pretty easy to drop the pack. You don't have to undo any connections. You just unbolt it, drop it out of the car, and everything self-disconnects. Getting it back in is a little tricky because you have to make sure everything is lined up perfectly, otherwise you can bend pins and stuff on those. So it's not quite as easy as it might seem to put it back in, but it's not too terribly difficult. But anyway, I'll go ahead and get the pack rolled out here. We'll get the top cleaned up, and the first thing I do before we open it up is, just like I did on my car, I'm going to do a pressure test on it, make sure that there's no leakage points. There definitely was quite a bit of water up here at the front of the pack. As you can see, it's pretty wet. That's fairly common. You just get a lot of sort of buildup of water here at the front of the pack on these. This does have the properly routed condensation drain, which goes over the hump of the battery and drains at the front. On the old cars, they literally dumped right there, right on top of the battery, which, you know, leads to even more water getting on here than this. But yeah, it doesn't look like our fuse cover is rusted out or anything, although our sticker's peeling up there. I don't actually know that this battery pack is original, because the sticker's missing. I suspect that it is likely original, though. I mean, it's got the old school gray cover, gray or greenish gray, whatever you want to call this. It's kind of like a sage color, I guess. But this is the original style lid. It's the old style pack enclosure. It does look like the pyro fuse has been replaced based on the orange bolt marks here. That's pretty common on this era of Model S. For several years, Tesla used a self-powered pyro fuse that has its own internal battery, and they basically just have a lifespan. The battery, you know, drains over time, so they actually have kind of a countdown timer built in, and after roughly 8 years, give or take, the car throws an alert and says the pyro fuse needs to be replaced. So it looks like that's already been done on this one, so it should have the current powered pyro fuse, which should never need to be serviced again. Yeah, up here we've got our coolant Rapid Mate, which of course leaked a bunch of coolant out when we dropped the pack, but it looks like it's pretty well sealed up now. It's not dripping anything anymore. Well, maybe a little bit. A couple drops here and there, but overall, not too bad. But yeah, we'll get this rolled out, cleaned it up. All right, so I got the pack all cleaned up. I went ahead and just kind of vacuumed all the loose debris off, wiped it down, and then I got my pressure tester set up here, and we actually have the valve closed, and the pack is holding pressure, so right at, basically 0.2 psi. I went around with my soapy water on all of the umbrella valves and everything, and it looks like we don't have any coolant, or not, we don't have any moisture intrusion leakage issues into the pack. The only place where we have a slight bit of leakage is through this breather valve here at the top, which is pretty normal. So usually you just kind of tape that thing off. But yeah, so this likely isn't a moisture intrusion related issue, which is kind of uncommon, but not too unheard of. But yeah, now our next step is going to be basically to get the pack opened up here. So yeah, I'll go ahead and get the pressure tester off of here, and we'll start prepping to pull the lid open on this thing. Pack here, I actually wanted to plug in my scan tool to it and look at some more. One was our one that we knew had a problem, but it looks like module 4 might also have an issue. But basically what you can see here is if we pay attention to module 1, if I click on it here, you'll see that this voltage delta keeps moving around, and both brick 1 and then I think it's brick 3 and I think brick 4 keep moving around, which is probably more indicative at this point of an actual issue with the battery management board, or BMB, rather than, yeah, see, that one went up to 3.9, 3.7, and that voltage delta just keeps moving around. So these cell voltages just are not stable, which indicates there's probably corrosion on that BMB, which usually if there's corrosion to one, there's multiple others that could be on the verge of failure. Module 4 here I've noticed was acting up a little bit too, but it's kind of intermittent, not quite as bad as module 1. But anyway, I'll go ahead and get all this stuff unplugged, and then we can get the pack opened up. We'll pull out module 1 first, which is located over here, and yeah, ultimately we'll end up pulling all of the modules out to inspect the BMBs on all of them, make sure everything's good, whatever needs to be replaced, we'll replace, and then we can put the pack back together again, seal it all back up, and it should be good to go. Alright, so before we go ahead and start pulling plastic off and opening the lid, I want to purge all of the coolant out of the battery pack. This will minimize any of our cleanup, because once we go and start disconnecting the coolant lines on the modules and stuff, we want to minimize the amount of coolant that leaks into the pack, and also that's dripping out of the modules when we're handling them. So we want to push as much coolant as possible out of the pack as we can. So I've got my low pressure set up, hooked up just to a rapid mate valve that is clamped onto the battery here, and I've turned up my pressure a bit higher. We're still very low pressure though, only 1 psi. I'm going to open up the valve here, and you can see we're going to start pushing coolant out. I might even turn up the pressure a bit more, say to 2 psi. That should be fine. Yeah, there we go. So there you go. Got a little bit of a leak, but that's fine. We don't care about that too much. We're just trying to push all of the coolant out. And once we start getting air coming out of there, I'll know that we've got as much coolant out as humanly possible. And then we'll shut this thing off, and then we can start actually opening up the lid, which will probably start by pulling the plastic sheet off and the fire blanket. And then we'll pull the penthouse cover off, and then we'll open up the rest of the lid, which I'll be able to show you guys that whole process. Mostly just got air coming out now. There's still a little bit of coolant that's making it out, but that's pretty much as much coolant as we can reasonably get out, so try and keep that from making a mess. Go ahead and shut our valve off here, and then I'll get our apparatus here all removed, and then we can start opening up the lid. Alright, so our next step is we're going to go ahead and peel this plastic cover off, and underneath this is a fire blanket, or a ceramic blanket, whatever you want to call it. It's basically a firewall between the battery and the car. They went a little overkill on the safety measures on these legacy Model S's. Sometimes with this plastic sheet, you can get it to peel up pretty easy. It's just sealed with like a butyl tape around the edges. And sometimes the stuff comes up relatively easily, and sometimes it's more difficult. But usually if you can get the butyl tape to separate from the lid, you just kind of work it all the way around like so. And I want to try not to stretch the lid if possible. I'll see you now. Now the stuff is separating from the plastic itself. That's always the tough part, is sometimes it wants to separate from the plastic, sometimes it wants to separate from the lid. There we go. So we're more or less fully separated there. Basically, I'll just kind of tear the butyl tape wherever I can here. And then I actually want to try and leave this plastic cover. There's some sort of double-sided tape in a couple spots on the lid here. I want to try and leave it attached to this ceramic blanket, because that'll make it way easier to get this thing properly centered on here when it goes back together. But now I'm going to kind of reach under and pick this up and just try to separate this from the standoffs in the center. Basically just has like a 3M double-sided adhesive on these. Okay, looks like we're fully separated there. Now the other thing I want to do is I want to avoid bending or creasing this blanket. So I'm actually going to get a big pallet over here with a piece of plywood on it. I'm going to slide this whole thing off so it stays flat. So I'll grab that with the forklift here. There we go, close enough. And I can kind of just pick this up. There we go. And now I should be able to just kind of slide this off onto my storage sheet of plywood there. So I'll go ahead and get that out of the way, and then we'll come back and get started on the rest of the lid. Alright, so the time has come to start getting all this stuff apart. So first thing I'm going to do is I'm actually going to remove the screws for our coolant rapid mate here. Get those loosened off. And of course the penthouse has to come before anything else on the lid, because it actually clamps this portion of the lid into place. So this always has to come first. Now on the smaller size 350 volt packs, this area of the pack is actually empty. This is of course a 400 volt 85 kilowatt hour pack, so it does have two modules stacked on top of each other right here. If it were, say, a 70 pack like the one in my car, this would be empty. Same goes for the 75 packs or the 350 volt versions of the 85 and 90 kilowatt hour packs, which are effectively a 100 kilowatt hour pack with two modules removed. There we go, we've got all of those fasteners out. Then I'm going to take these little standoff pieces out. These are actually the bolts that go through the center of the pack. So they come up through the bottom, and this is actually hollow all the way through, and the bolt would go into the floor of the car. There's two up here at the front, there's 8 more in the middle, and then there's 2 more at the rear. We'll go ahead and get that loosened off. This is just a 10 millimeter Allen key. Dang, that thing is pretty stuck in there. You want to be careful because on some packs these can actually be reverse threaded. So let me make sure that we're not reverse thread there. I think it's really only on the later ones where they did that, but we might have some pretty significant corrosion going on here, so these can be a pain in the butt because it's actually an aluminum fastener. This is aluminum, and the piece that it goes into is aluminum, so if there's any kind of corrosion in there, it can cause some problems. You also don't want to push down too hard on it once it gets started coming out, because you can push the bottom side out, and that leads to even more problems. Let me keep messing with this a little bit, and I'll see if I can get it loosened off. I might have to get some extra leverage on it, because, yeah, I cannot get that thing to move. It's moving a little bit, but not much. I think I just want to keep working it back and forth to try and break it free, and not risk damaging the threads or anything on that. So I'll keep working on that, and then once I get those out, we'll come back. All right, looks like I just needed a little bit more leverage on this thing, so got that started. I think I can get it loosened off the rest of the way here. Yep, that's definitely coming out. And again, like I said, you just don't want to put too much downward pressure on it, because that can cause some problems where it actually pushes the bottom end of this thing out, and then it's extremely difficult to get those back in seated where they won't spin. There we go. There's that one. Let's see if the one on this side is just as stubborn. Oh no, that one wasn't so bad at all. I do know that when I pulled the bolt out on that side, there was a lot of water that came out that was sitting on top of the pack from that bolt, so not too uncommon. But yeah, we'll go ahead and get that one loosened off all the way. There we go. There we go. Yeah, you can see how crusty that thing is on the end. That's why it was fighting us so hard, just corrosion. So anyway, those are off. I'm actually going to leave the pyro fuse cover on, because that can actually stay attached to the main lid here. If it were really badly rusted or corroded, I would pull that off first. But that one looks clean, so we're just going to leave it alone, and we'll just continue pulling off the whole lid here. The rest of the bolts on here are a combination of, these are M5 nuts, which are, you know, an 8mm hex. There's a couple of M5 bolts here as well, and then the rest of these are all M5 with a T25 Torx head. So we'll start with all the 8mm stuff. Get all that stuff broken loose, and then we'll come back when it's time to pull the lid off. All right, all the fasteners are out. Now it's time to separate this thing. So I'm going to use kind of a combination of tools. I've got sort of just a big scraper, separator, blade, whatever you want to call it. I've got sort of a small pry bar that happens to have sort of a really flat, narrow end, which is going to be helpful to get under there. And then, you know, just a hammer to help kind of drive those in. And for the coolant rapid mate, I find that the easiest way to get that separated is once we start to pull on the lid, we can kind of hook this in and sort of pry that down to sort of push the coolant rapid mate off of the lid there. Yeah, that's sort of the trickiest part about getting this thing off, is that the rapid mate wants to stick to the lid. The other thing to be cognizant of is, of course, there is a pair of modules in here, so you don't want to be shoving tools in there too far. I just want to get this thing separated enough that I can start to peel it up. You know, I want to go in no further than the edge of the flange on here, except for kind of in this section, of course, you can go a little bit deeper, but on the front and the back, you don't want to go any deeper than the flange, because you don't want to run into a module or a bus bar or anything like that. So I'll go ahead and start getting this thing separated, and yeah, we'll come back when we're starting to pull it off. Alrighty, a couple clips here where the audio didn't quite work out, but what I'm doing here is I'm just peeling up the lid on the penthouse cover here. So I've already got most of the adhesive cut loose, so I'm just trying to get the lid separated. The back portion where all the studs are is the toughest to separate, just because you can't really get in there. So I'm using a pry bar to kind of assist. I'm trying to be as gentle as I can with it, because I want to avoid putting any big creases or bends in the lid. So I'm just kind of trying to pry it up a little bit as gently as possible to try and get the lid to separate here. And then from there, I'm just kind of pushing up on it, trying to get that adhesive to come loose. I got the whole front portion up there, as you can see. So I'm just kind of trying to wiggle it back and forth to get the whole thing to separate. And there we go, it's all separated. Got a little bit of a bend in the lid there, but we can straighten that back out once we have the rest of the lid opened up. That's not too big of a deal, just as long as we don't have any big creases or anything. So we'll be able to flatten that back out, no problem. Alrighty, so the next step here is going to be getting the rest of the pack opened up. I'm going to be using what's generally referred to in the community as the butterfly method, which basically involves taking the fasteners out around the periphery and in the ribs, but then the center spine is going to stay intact. There's another method of opening up these packs, which is generally referred to as the sardine can method. And essentially what that involves is you take out all the fasteners and then try to peel the whole lid up, and it basically ends up getting all coiled up just like a lid on a sardine can. You end up with a lid that's sort of bent up into a big coil that causes a lot of issues, quite difficult to get straightened out again, and very time consuming to do so. And even then, it's still almost impossible to get it fully straightened out without any creases or anything in it. So the butterfly method is a much cleaner method to get the pack opened up, and you end up with just a lot less difficulty. But essentially, we're just going to leave the center spine intact and then fold each side of the pack lid up and out of the way to gain access to the modules, and then fold it all back down when it goes back together. You just end up with one real small crease at the spine for each side that basically almost completely flattens out when you get it back together. You almost can't even tell the pack was ever even opened up. So it's pretty much just as simple as that. We'll go ahead and remove all the fasteners, and then the hardest part is just getting the adhesive removed along the two sides of the pack, since the edge of the lid is kind of folded over. I have a method for that with just kind of a special tool that I made, and I'll be able to show you guys that when we get to that point. But yeah, that's pretty much as simple as it gets, and not too difficult of a process. So now all the fasteners are out in the lid. All that's left to do is to go ahead and get it the rest of the way opened up. We've got to slice through all the adhesive in order to free the lid from the body of the pack. Now on the very front and the back, I can get through it using basically the same method that I did on the penthouse cover. Just kind of slice through all the adhesive, but on the edges, we've got this kind of curved side that gets in the way of being able to do that. So I've actually got a special tool that I made specifically for doing that. That's this thing right here. Just sort of a modified piece of angle with a bit of a sharp edge cut on both ends. And it fits the profile perfectly in here to fit under the edge of that lid. So basically what I'll do is I'll get it started with a hammer, and then I will drive it the rest of the way through the lid with an air hammer. Works quite quickly and efficiently. You don't have to end up beating on it with a hammer. We don't have to bend the lid up in order to get that edge apart. And it's super quick and simple to do, and it gets the job done quite easily. Alright, so I got the corners and everything all peeled up, started. I've got my ear protection on since the air hammer here is pretty loud. What I'm going to do here is I'm just going to get this thing kind of started in here, just by hand. And then we can come in with this thing and just shove it through. I've got a pretty small compressor, so I'll let it catch up, running out of air, so losing power. But anyway, I'll just keep going through this whole thing, and then once I get both sides opened up, we'll go ahead and peel the lid open. Alrighty, so all the edges are undone. We should be good to go ahead and peel the lid up here. I'm actually going to take this same little pry bar that I was using earlier, and I'm going to use it right where the ribs are here. just kind of get this started because there's probably still a little bit of sealant holding this in. Just get that sort of shoved in there, and there we go. We can kind of pick that up, and I'll work my way around to the next one. Let's see, is that enough to get us started? Maybe not quite. There's always a little bit of extra adhesive right where the ribs are, keeping the lid sort of attached. There we go. Alrighty, there we go. So now we should be able to just kind of pick this up. There's probably going to be adhesive on the inside of that as well. But I think that once we get it started going up, it should kind of peel on its own. There we go. And we'll just push. And look at that. There we go. We've got one half open. And I'll just copy that on the other side as well. All right, so we've got the whole pack opened up here. Both sides are butterflied open. We're ready to start pulling modules. Before we do start pulling modules, though, I kind of wanted to go over what I think is a little bit of an important topic to think about when talking about Model S packs. So the legacy Model S pack has kind of a weird, unintuitive layout if you don't know what it is that you're doing. So the module numbers and the way that the modules all communicate with each other serially is starting with 1 here, and then going 2, 3, 4, 5, 6, 7, 8 on the bottom, 9 on the top, and then back the other way down the row with 16 being the one at the end here. That's the way that it talks about the cooling loop and the actual like brick numbers, but it's not the way that the modules are laid out in terms of the way they're connected in series for the actual high voltage architecture. And that's the part that's unintuitive. So the negative side of the pack, which, you know, kind of you could call the first cell group in series, starts with this module, so module number 16, and the negative terminal is actually on this side of the module. So from this side of the module, there's a bus bar that goes through the spine of the pack and ends up at the negative contactor here. But then this module is connected in series to module 1, which is then connected to module 15 and so forth. They zigzag back and forth through the pack, ending up at the very end where the positive most module is this module on the top. Yeah, the topmost module is the positive. And yeah, essentially that's the way that ends up working. So it's kind of not the most intuitive setup. But yeah, so this bus bar that ends up at the high voltage pyro fuse here actually comes off of the third to last module. Is that right? Yeah, third to last module. So that comes out of the spine, curves around here, connects there, then it connects in series to the module 8 there at the bottom, which is the second to last, and then the last module in series is module 9 at the top here, and then that goes all the way back along the spine to the positive contactor. So a little bit of a convoluted pack layout, and a lot of people think if you pull this fuse out, that, you know, makes the pack safe. But really there's still almost full pack voltage here. So if you take that fuse out, if this were a 14 module pack, you're just taking out the fuse at the positive end. In this case, you're removing 2 modules if you pull that fuse out, but there's still, if the pack were fully charged, 350 volts of potential between that fuse terminal and the negative end of the pack. But yeah, so just wanted to discuss that. When we're talking about module numbers or the brick numbers, it's not where the placement is in series within the pack. It's actually talking about just the architecture of the way that they communicate with each other, which does not match the way the modules are in series. Does So just wanted to clear that up. But our module that is our most problematic one is going to be module number 1 here. So that's the one that has the biggest fluctuations in voltage going up and down that's causing all sorts of weird faults. It looked like module 4 was also doing some weird stuff, and maybe a couple of other ones were doing some oddball things as well. But yeah, it looks like it was mostly that one. And actually, looking in here, you can see all this condensation, which is going to be the biggest cause of our problems there. I can't tell if that is glue. I don't know what the heck all this white stuff is in here. We'll have to take a peek at that and see what's going on, but it's right there at the end. I don't see anything wrong with the connections here, but the brick 3 connection, which was the biggest one that was causing the main problems, will be on the bottom side of the module. But yeah, definitely a lot of condensation here. That looks like it's water. Doesn't appear to be coolant. You can see it here on the lid as well. Yeah, that's definitely clear water. If it was coolant, you'd see blue there. So definitely moisture intrusion. The question is, where was it coming from? Because this passed our pressure test with no issues. So maybe we've got some other. Yeah, that's weird. Normally I would expect to see a failure on the pressure test if there was enough moisture intrusion to cause this issue. But, and then again, this is, basically a 10-year-old car at this point. Actually, it's over 10 years old now. So I guess maybe it's not too terribly surprising that there could be some moisture intrusion issues going on here. Do we see anything on the other side here? This side looks pretty good. Maybe a tiny bit. Yeah, there is a little bit of moisture on those coolant hose connections. Not seeing anything too crazy there. But anyway, I'm going to go ahead and get the high voltage tools out. We'll pull out module number 1 first, and we'll take a look at that, see what's going on. Alright, so first order of business here is going to be to disconnect the coolant lines. So I'm just going to use kind of a tool here. And then these are just a quick disconnect fitting, so we just want to pull that tab up. And then we should be able to push the fitting off in this direction. Of course, we want to be careful not to break anything. But the lines do have some flex in them. They're plastic though, so still got to be careful. But they're not too bad. The tough part is just getting it started. There we go. That one's fully off. I can do the same thing, just push that out of the way. And the reason why we drained all the coolant out was just to keep these from dripping, so this shouldn't have hardly any coolant in it at all. So I should be good to just kind of push this down where it'll stay out of our way. And we shouldn't get too much leakage, although I am getting a couple drips out of it. But we should be okay there. Now we can move up to the front of the module where we'll disconnect the bus bars and the serial connection on the BMB. All right, so up here at the front is where we're gonna disconnect our BMB harness, which I'm gonna do first. So I'm just gonna take my insulated screwdriver in here, and I'm going to gently pry against the plastic housing here. It is just thin plastic, so we don't want to crack it or anything. And this is, of course, an insulated screwdriver, but there's a tab on here that we want to get disconnected, which I think I just heard it pop loose. We should be able to pick the connector up here, perhaps. I think we're good. Yeah, there we go. Just want to be careful not to break the tab off. There's just not an easy way to get to it in there. But basically what I'm doing when I'm pushing in there is I'm trying to push that tab open like that. So anyway, that's disconnected now. Next we can remove our covers that go on the actual terminations for the bus bars. And then we'll take our insulated ratchet here, which I'm going to try and push this lid open just a little bit more to get some extra clearance. I might have to grab a different wrench here. These offset box end wrenches work way better in here for this, just to get it started. And then I'll take the insulated socket and just unscrew that by hand. Obviously I'm not touching the bus there, just the socket, which is insulated. I'm going to go until that's completely loosened. Do the same thing on this side. And obviously this pack does have good isolation resistance. If this were a pack that had a loss of isolation, I'd be much more extra super duper cautious. Obviously still want to be cautious here. There is high voltage present, but we know that the case is isolated from that. So as long as we don't have any tools touching the high voltage bus or anything, we should be okay. But anyway, I'm going to go ahead and get these bolts put in my storage tray, and then we're going to pull this module out. All right, now probably the hardest part of this whole procedure is going to be getting the module out, which I just realized I forgot a step, because we do have to remove this bar for module 1 here. So let me actually remove that. It's just got a few T30 fasteners in it. It's just pretty stuck in there with the adhesive. So I'll grab that out of the way, set that aside. And now we can remove the module. So I'm going to take kind of my hook tool here, and I'm going to hook it under this edge. So the modules have these rails on the sides where they sit on. So I'm just going to stick that right under that rail on the edge, and pick that up enough that I can get another tool in, just to hold it up on this side, which this tool be better suited to go over here. There we go. So I'm going to pick that up far enough that I can get my fingers under it. Which of course we're getting caught on a coolant line there. But I can get my fingers under it, pick it up further, and then we'll slide it out a ways. Far enough that I can cantilever it, pick it up, and then I'll bring it over to the table where I'm going to work on these. All right, so this right here is our problem module. Of course, this is the one that was throwing the majority of our faults, but we did look like there were a couple of other ones that were a bit sketchy as well. What I am going to do here is I'm going to pull this top cover off, just like so. I'm looking at the BMB here. I don't see any major signs of corrosion on C26 and C27. So that's looking all right. So now what I'm going to do is I'm going to gently flip this over. Now I have a plastic sheet on here that will keep this from contacting the actual table. We want to be careful of the wire bonds here because they are quite delicate, but they do sit below the surface of the actual collector plates. So just want to be careful with it. Gently flip it. And when I say gently, I mean very gently. I'm actually going to slide this over this way a bit. Okay. And now what I can do is I can pull this side of the collector plate off, and it looks like I have found our problem. I'll bring you guys in for a close-up here. Alright, so I don't know how well that shows up on camera. It looks a little bit dark, I guess, so let me grab a light. but that copper wire where it attaches to the collector plate that's pretty crusty looking, and looking at it kind of from the side here, it looks like it's not really attached. Yeah, so you can see I can just pick that right up off of the module, and it is not attached properly anymore. So that right there is our main culprit. The BMB looks fine from what I can tell. And yeah, that's definitely our main issue. So that's our brick 3. That was the one that was throwing all the faults and not making a proper connection. So this is basically ultrasonically welded to the collector plate. The collector plate here is made out of aluminum, so that makes it extremely difficult to attach to. Can't really solder to it. If it were really a small part, maybe you could solder to it like if it was an aluminum wire, but this has so much thermal mass since it's a big collector plate, you'd have to heat it up a bunch to get it to take any solder, and obviously we don't want to heat it in close proximity to the cells like this. So rather than soldering this to the collector plate, and we can't really ultrasonically weld it either since I don't have that kind of equipment, nor do most other shops, what I'm going to end up doing is I'll probably end up attaching another wire to this one, and then we'll run the wire further over in that direction to the edge of the collector plate. We'll put a tiny little ring terminal, and we'll actually rivet the wire down to the collector plate. And that's a pretty good solid repair for these. But let's go ahead and take a look at the other ones and see if we've got any other problem areas, because it looked like there were some other cell groups that were also throwing some sketchy voltage readings. So these are our next two on the collector plate. This one looks pretty corroded as well. It's still attached, which is good. How about this one? That one is still attached as well. The copper is definitely a little bit oxidized, but it is attached to the collector plate. I'm going to go ahead and flip this module back over, and we'll look at the ones on the other side as well. All right, so we've got 4 more voltage sense wires on the top side. So we've got these 2 here and these 2 here. Again, they do look like they have some oxidation, but they appear to be solidly attached. So that's good. The reason why we would have had voltage readings that were sketchy on both brick 3 and brick 4 is that these sense wires work for 2 bricks in tandem. So this would be the negative most, this one is the negative most sense wire. And then for brick 1, I do have that correct, right? I think I've got that order correct, yeah. So this technically is what they call the brick 0 sense wire, because it's not on the positive end of a brick, it's on the negative most side of the pack. So this is brick 0, or the negative most sense lead. For brick 1, the positive one is going to be on the bottom side, so that would have been the one that was probably closest to this end. I don't remember for sure off the top of my head. But anyway, brick 1 would be on the bottom side, and then brick 1, that wire for the brick 1 measurement, also acts as the negative for the brick 2 measurement. And the brick 2 positive measurement is going to be this one right here. So this is brick 2 positive, and the brick 1 is the negative side for this one. So in the case of the brick 3 and brick 4, the brick 3 voltage reading is reliant upon that sense lead that was in the middle on the bottom, and that's going to be the brick 3 positive side as well as the brick 4 negative side. So it affects both of those measurements. But yeah, effectively that's the main issue there, is that we've got just a disconnected sense lead. So that should be repairable. It's getting to be the end of the day here, so I'm probably going to wrap this up here for now. But what I'll do is when I come back to this, I'll do the repair on this module, but I also want to pull the other modules out of the pack and check them out, because it's not worth, you don't want to just do one and then put it back together. We want to make sure everything's sorted. We've already gone through the work to pull the pack and open it all up. We want to pull all the modules, make sure they're all good. We know that there's moisture intrusion because we did see signs of condensation, so we want to check the BMBs on all the modules. So we'll check all the BMBs, check the sense lead connections, make sure everything's solid, fix any that need to be fixed, and then we should be able to put this thing back together. Okay, so we're at a point now where I'm ready to go ahead and repair our disconnected sense lead issue. So of course we can't solder to this because our collector plate here is aluminum. Soldering to aluminum doesn't usually tend to work very well. And of course copper wire, so we've got differential materials going on there. But what I can do, and this is usually the repair that it seems like a lot of other shops that I've seen do, is I'm actually going to take this wire, I'm actually going to peel it out of the little holder in here, and I'm actually going to cut it a little bit short. We'll cut it back to about here, maybe. I think that'll work all right. And then what I'm going to do is I'm going to strip it. Of course, being careful, we don't want to touch our conductive tool on the collector plates or anything. Of course, these are teeny tiny little wires, so I don't know if my wire stripper can even strip that stuff off of there. I'm going to try and peel this back here a little bit further, and yeah, I'll bring you guys back once I get this stripped off. Alright, so I successfully stripped that back, and now what I'm going to do is I'm going to take another piece of wire here, which is about the same gauge. I think this one is actually just a tiny bit larger, but that's fine. And I managed to get one that was the same color as well. And I'm just going to crimp this together very carefully. Of course, I want to make sure to get all of the strands. Give it a little pull test, and it failed our pull test. So I'm going to need to get a little bit stronger crimp on there. Alright, we're back with the crimper. I'm actually going to crimp it just up here kind of at the top, because this part of the crimper doesn't actually crimp small enough for these teeny tiny little butt connectors, but on that I can get a pretty good squeeze on it. So that's exactly what I'm going to do. So we'll go ahead and get this back in, and we'll get it crimped. Okay, we'll give it a pull test. Okay, that's good and solid in there. And then, let's see, I'm going to put just a clean towel on that. We'll get some heat shrink back here. And now what I'm going to do, I'm going to kind of push this into its little groove here where it's supposed to stay. And then once we get to the end of that, I'm going to have it go to the outside here. We're actually going to run it, probably can't really see it very well on camera, but there's sort of our little rectangular shape here in the plastic. I want to have it go on the outside of that so that this wire doesn't get pinched anywhere. And what we're going to do is we're going to run this wire all the way to the edge of the collector plate here. And what I'm going to do is, first of all, I want to make sure the wire is at the tightness. I want it to be relatively tight. I mean, we don't want to be putting a ton of strain on it, but I want it to be, you know, about like so. I'm going to cut it to length here. So we're going to go probably right about there. I'll give it just a tiny bit of slack, just in case. We'll strip this end off. Oh, got a little stray wire here. There we go. And now what I'm going to do is I'm going to take a teeny tiny little ring terminal. These are, I think, number 3 ring terminals. It's just an itty bitty little guy. And what we are going to do is we're going to crimp that guy onto the end of this wire, just like so. Actually, I want to strip just a tiny bit more off of that. I stripped it just a touch short. Okay, and crimp. Just a little extra on the end here. Once again, pull test, and I think we're good. So, I made that just a touch long, but that's okay, because we can have a little bit of slack here. Alright, I'm going to just set that off to the side here. Now what I'm going to do is I'm actually going to drill a little tiny hole through the collector plate here, and this spot right here has a pretty good overhang under it. Like if I take my tool here, you can see I can stick that in there pretty far. And what I'm going to do is I'm just going to drill a little hole right in the end of that, and we're going to rivet this ring terminal down with just a little tiny 3/32 rivet. And that'll give us a solid connection where the BMB will still be able to make its cell voltage measurements, and it'll be a nice permanent fix for this. Let me go grab my vacuum, because I will need to make sure we don't get any chips caught in here. And yeah, we'll just drill that little tiny hole in there. Alrighty, so we got our little hole drilled in there. I'm gonna put just a little bit of this stuff on. This is just an anti-oxidizing compound. I'm just going to put a little bit of that stuff, just the ever so slightest little coating on the bottom of our ring terminal, because we do have slight differential materials here with the copper ring terminal, or really it's silver plated copper, and then our aluminum collector plate. So we'll just get a little bit on there so that we don't get any long-term corrosion issues if moisture intrusion ever occurs in this thing again, which hopefully it shouldn't once we get it all sealed back up. But we want this to last as long as possible. Getting it back on the road is easy. Keeping it on the road is the harder part. So I'll try and get that positioned roughly where I want it. If we get just a little bit of waviness to this wire, that's okay. I'm going to take just my rivet tool, push down, and there we go. So we've got a good solid connection there. I'm going to hit this with the heat gun just a little bit. I might actually just kind of pick that up a little bit so we can kind of get it sideways, not blow heat directly in there. So let me go get that real quick. Alright, my offset on my heat shrink wasn't very good there, but that's okay. Get that pushed back in right there. And there we go, we're pretty good to go. All that I'm going to do now is I'm just going to add a little bit of Kapton tape just to secure this wire in place so it's not just wobbling around in here. So let me grab some of that and stick it on. Alrighty, we'll go ahead and get our wire taped down into place here. Like I said, I want it on the outside of this little rectangle. And we'll just give it kind of a little, maybe a little bit of an S-curve there. I'm just going to take probably a short piece of this for now. Of course, I don't have my scissors to cut this. Let me get my knife. Just going to get kind of a shorter piece here to get it started. There we go, and then just give this a little bit of an S-curve right there. I'll give it just another little piece of tape to hold it in place there as well. There we go. Probably could have made my wire a little bit shorter to make that a little cleaner, but that's all right. That worked out okay. And now really all that I've got to do is I've got to pull out all 15 other modules out of the pack, inspect them all. I think that there might be another one that either has this issue or potentially a bad BMB. One of the ones in the front module stack I can actually already see has a corroded BMB. I'm sure there's several that will need to do BMBs and or this same repair. The BMBs are really the more common issue that I'm most worried about. So anyway, yeah, I'll go ahead and continue along on this, and I'll show you guys if I encounter any other issues. So just another thing I'm going to mention here as I'm putting this module back together, I've got the bottom plastic shell on it, and I'm about to put the top shell back on. But what I'm going to do first is this plastic tab on the shell, I'm actually going to remove, and you can see it has a perforated edge right here. So I'm just going to fold that right on that perforated edge and work it back and forth a little bit. Maybe. Yeah, might have to work it back and forth a little bit more. Just weaken that plastic right on that edge. There we go. Anyway, so now we've got that tab broken off. The reason why is that when this module is fully assembled and the top piece is on it, that tab actually presses against the upper part of the board here, usually right against these two capacitors, C26 and C27. So that's those guys right there. And when that gets pushed up against it, if moisture intrusion occurs in the pack, that when that tab is pushing up against those, moisture tends to condensate right in between there. And in addition, because this is sitting up right against that, you know, as you're driving around, this has a little bit of vibration and it rubs the conformal coating off of those capacitors. And in combination with moisture intrusion and increased humidity, if it starts to condensate, it actually corrodes those capacitors away. And that's actually a super common failure mode, much more common than the other failure mode we fixed on this module. But yeah, I think that there's certainly going to be multiple modules that have BMBs that are probably starting to have that corrosion on those two capacitors. So as I pull this pack apart, if I encounter any of those, I'll bring you guys in and show you what that looks like. All right, so we've got our first failed BMB here. Well, not failed, but just signs of corrosion. So we are going to replace this one. But the places that we're looking for corrosion are right here, C26 and C27. And you can see the top side of C27 here has just a little bit of corrosion starting. We've also got some funkiness going on with diode 14 here as well. That's a little bit more unusual, but I have seen issues with those before. But really, these are typically the main culprits. And that's also why we want to break that tab off of the plastic, shielding on here. Is that tab is what rubs up against those capacitors and ultimately leads to the conformal coating getting worn through, and then in combination with moisture in the pack, you end up with these corrosion issues. So I'm going to go ahead and swap this board out with another one, and then this should be good to go. All right, so I'm just going to pull all these little pins out. So there's these little kind of plastic clips that hold this thing in. They have a center pin that pulls out just like so. So we get all 4 of those. Then once those are out, I can kind of just pull on the board, and then the rest of the clip will kind of pop out. Sometimes it helps just to have a little bit of leverage on it, but Let me get a tool here real quick. There we go. And then if we kind of flip this board over, you can see we've got a connector here on the back side that we've got to unplug. Just push down on that tab, give the connector a little wiggle. And then there's also one over here, that's for the temperature sensors within the module. Same deal there. All right, we've got our replacement board here. I didn't even really look at these to see if they were the same revision number, but it looks like they are. They're both a -A revision 1 part, so it's actually a 1-for-1 replacement. Doesn't really matter, they're all cross-compatible. But yeah, so we'll just plug this in. Just like so. Get one there. And one there. Then we can just kind of put that into place and push our little pins in. And this is by far the most common type of failure mode that I usually see when it comes to moisture intrusion on these packs, is these BMBs start to fail from exactly what I was explaining there. C26 and C27 are typically the main culprits. Usually when that happens, the stereotypical failure mode is you'll have bricks 5 and 6. Is that right? I think it's bricks 5 and 6 will have one brick that reads higher than average and one brick that reads lower than average by equal and opposite amounts. And that's usually kind of a telltale sign that it's an issue. There we go. So all those are in, they're all connected, and this module's good to go. Alrighty folks, it's been a hot minute since I did an update on this pack here. It's kind of been on the back burner as I've been working on some other stuff. But I've gone through all 16 modules and checked the BMBs on all of them. In the end, I ended up needing to replace 5 of these boards. And of course, there was only one that had the separated sense lead on the bottom, which we took care of that one. I inspected all of the other ones, and all the other ones appear to be secure and not at risk of coming undone. So what I've done here now is I've got the pack all back together. I've gone ahead and cleaned up all of the sealing surfaces on it, and I've touched up a few areas just with some spray paint, which I've got right here. So this happens to be pretty dang close matching color. You can actually see here where I touched it up on the corner compared to the stock color. I'm pretty close on that. But yeah, that's important just to prevent any kind of corrosion from forming, because bare aluminum, of course, can start to corrode if left exposed to the elements. So we want to cover up any bare aluminum wherever it might have gotten scraped off when I pulled the gasket material off of here. Now all it's really left to do is I've just got to peel off my labels on the modules, get the mica sheets back on everything, and I want to plug in to our port here with the Autel, make sure everything's working properly, and yeah, then I'm basically just going to let this thing sit overnight to make sure the paint gets fully cured, and then we'll be able to get the sealant down, fold the lid back up, and get this thing all back together so that it can go back into the car here. So yeah, let's go ahead and get the Autel plugged in real quick before I head out for the day here. And then, like I said, I'll come back in the morning after this paint has had a good chance to cure, and we'll get everything sealed back up. Alrighty, so we've got our setup all connected here. So I've got the adapter from that plugs into the Tesla pack into our EV Diag box, which is then plugged into the VCI. And now we can go ahead and connect to the battery and make sure that everything is good that we are looking for here. Where is Tesla on here? Let's see, I guess we can search, that'll be easy. Boom. Yes, accept. Yeah. Yes. Let's see. Yeah, we don't want to do that because that's not probably going to work very well. So we want to go North America. Why is it on? We want to do manual selection, North America, Model S. Interesting. We'll try auto selection here. I know I've connected to a Model S pack with this thing before. Not sure why it's not popping up as an option. Let's see, we'll go Tesla again. Maybe I missed something here. Manual selection. Maybe if we go all. Yeah, there we go. We had to go all, not North America. Okay, so we've got a P85D pack. Not that it should matter for this, but we'll go ahead and let that initialize here. And it'll go through a communication process and it'll wake up CAN bus here. We want special plug diagnostics. There we go. So that's our connection set up here. We do indeed have that going on. I hear some clicking coming from our diag box here. And I believe we're connected. So let's go here. Establishing communication. All right, and would you look at that? We are connected. So it looks like check or replace battery pack. We've only got a 9 millivolt delta, which is pretty good. I'm guessing that it's saying we need to address it because it probably has stored alerts in the BMS here. Or do we have something else going on here? Module 1 and Module 2 did something funky there for a minute. Fascinating. Module 1 and Module 2. Yeah, look at that. It's giving an errant voltage reading on that one. And on Module 2 it was doing it as well. I might have to do some further checking here just to confirm and make sure there's no issues. I don't know if we've got... This might be a bug with this program potentially. Or is it doing that because the pyro fuse is not installed? Could be. I mean, everything looks pretty good here. It's just we're getting some weird readings that vary on that. So I'll have to probably do some double checking here, make sure everything looks good, and then we'll be ready to get this thing sealed up tomorrow. All right, so I think I've confirmed that that issue is a bug. I have my other BMB reader here. This plugs directly into a single BMB, and by looking at this I can confirm that the cell voltages are not bouncing around like it's showing on the Autel, so there must be some kind of bug there. I mean, this is right at just between 3 and 4 millivolts, and it's holding steady. It hasn't moved at all. I'll go ahead and plug it in at number 2 as well, just to confirm that that one's the same way. But yeah, I don't think that we actually have any issues here. I think that we must have some kind of bug, probably because the BMS has a stored fault maybe, and there's no way to actually clear the faults directly with the pack out of the car like this. And funnily enough, after I unplugged that BMB, now all of the data here is just stuck, and it doesn't keep moving that around. So I don't know, who knows what's going on there, but yeah, I think we're okay to go here. And so I'll get this stuff all put away. We'll come back to this thing in the morning, get it all sealed up, and reinstall this pack back into the car here. Alrighty, so one more thing that I want to do before we get the pack sealed up is I want to replace all of the umbrella valves along here. Probably would have been smart to do those when I had the modules out of each individual bay, but not a big deal. So I'm going to go ahead and pry these ones loose, and then we'll install the new ones that have only got 2 valves, and then the rest of the spots are all blocked off. So a lot less potential failure points, and certainly a lot less likely to have issues in the future. Alright, well I meant to do a time lapse of that, but apparently it didn't save. Anyways, I went ahead and got all of the old umbrella valves out, which of course, that right there is what the old ones look like, so they're just single pieces. And yeah, they all just pop right out of there, no problem. And then I went ahead and swapped them all out with the newer style, which of course just has 4 empty slots with 2 umbrella valves. So this side's done. I'm going to go ahead and do the other side, and then we're finally ready to get this thing sealed back up. All right, it's finally time to get this pack sealed up. So everything is all sorted, everything's connected, we've tested it, our umbrella valves are in, time to seal it up. So I'm probably just going to time lapse through this, but basically what I'm going to do is I'm just going to apply our sealant material around the perimeter here. And then I'm going to do this one half at a time. So I'm just going to do this half of the pack first, get everything tightened down over here, then I'll fold down the other half of the pack and do that side. And yeah, that's pretty much how it's going to go. So let's go ahead and get this party started. Alrighty, so that's this side pretty much done, other than just in the ribs in between, but that we don't have to worry about too much for now. So now we can go ahead and move on to the other side. I'm not going to bother filming that because it's the same process that I just did here. But yeah, there are certain fasteners that have to go in certain places. So the majority of the fasteners that go along the periphery here are all the same, but the ones at the very back here are slightly different. And then there's also these ones right here that actually have sort of a sealing washer on them. And then there's a couple at the front that are also kind of the same way, where they're these different flanged heads on them. And of course I just stuck my finger in the goo there. So anyway, I'm going to go ahead and get the other side sealed up, and then once we're done with that, we should be able to get the penthouse cover on, and then we can start fastening all the ribs and stuff down. Alrighty, now it's time to go ahead and get the penthouse cover on. Once again, I'm just going to time lapse through this, but basically I'm just going to put down our bead of sealant and then get the thing in place and tighten it down. On the back side here, there's a bunch of studs. Kind of have to be careful with those because sometimes they can spin and then everything has to come back apart to address that issue. So want to avoid that. And yeah, other than that, it's just a matter of getting it all tightened down. So gonna get to it. Alrighty, there we go. Pack is all sealed up all the way around. All that we have left to do is install our fasteners in all the ribs here, as well as these little standoff doohickeys. I've actually got some new ones to replace these. These can kind of be reused, but the 3M, the sticky stuff on here doesn't really like to re-stick to things. So if you apply an adhesive to this, you can get the plastic sheet to re-adhere. I've just got a set of new ones. They're not that expensive. So we're going to go ahead and throw those on. But yeah, that's pretty much all that's left here, is just getting everything the rest of the way back together. Yeah, pretty straightforward. Alrighty, all of the rib fasteners are in. We've got our little whatever standoff things. These are actually where the bolts for the center part of the pack come through. I haven't peeled the stuff off of there because we still need to put the blanket on, and I want to save that until the last minute just so those don't get contaminated with anything. I'm pressure testing the pack right now to make sure it is sealed up, and it appears to be good. It's been holding steady right there at whatever that is, about 0.15, 0.2 psi. I've actually got the valve closed here, so it is holding pressure at that. So I think we're in good shape here. All that's left to do is to get the ceramic blanket and the plastic sheet back on, and then we can finally get this thing installed in the car. Alrighty, so we've got the ceramic blanket back onto the battery here. I've got a roll of butyl tape here, so I'm going to go ahead and just apply this around the perimeter of the battery, and then we can peel off our little covers on these and actually get the plastic sheet on. I want to make sure that it's sealed because we don't want moisture to get under it and condensate and whatever. The big issue with moisture getting in is that it can actually pool up in the ribs here, and then you can end up with water basically being able to corrode around the bolts and stuff and get in that way. It's actually a relatively well-known issue on really early packs, on like the 2012 and 2013s, especially because they actually dump the AC condensation right at the front of the battery up there. And yeah, that literally ends up with just water pooling up on top of the battery and causing problems. This one, of course, is a little bit later, so it actually already had the plastic sheet and all. But yeah, like I said, we want to make sure it's good and sealed up. So go ahead and get the butyl tape on here, and then we can get our sheet back on top. Alrighty, so we've got our butyl tape laid down. We can go ahead and peel off these little guys here. By the way, a 20-foot roll of this butyl tape happens to be like the perfect length to go all the way around the perimeter. You get just a little bit of overlap where your seam is, and yeah, it's basically spot on. And I usually use 1/2 inch by 1/4 inch. It's a little bit wider than what this had originally, but that gives it a better chance to be nice and sealed up when we go to get this sheet back on there. So almost all of these get this piece peeled off, except for at the very front there. All right, I got interrupted there by a transporter trying to drop a car off, but now we can go ahead and get our plastic sheet onto the battery here. So I'm going to try and get this on here without touching anything as much as possible. So I don't want it to stick like that. It's a little bit tricky to get it lined up properly without getting stuck to everything. But what I'm mainly going to try and do is line it up with the holes here in the center portions. They're a little bit twisted. Okay, I think we're pretty close here. I think we're good. Or at least close enough. So we're all adhered on these. And now all that's left to do is just make sure this gets pressed down into the butyl. And yeah, I want to make sure not to stretch this sheet at all, because we want this to be fully adhered. And we don't want to end up with any big creases anywhere, because otherwise it won't seal. There are inevitably going to be some kind of little creases in here. We just want to avoid the big ones. Alrighty, there we go. Plastic sheet is all installed. I'll go around and give it a once over just to make sure there's no air bubbles anywhere where any air or moisture would be able to make its way under the blanket here. But yeah, that's pretty much it here. I think we're about ready to stick this thing in the cart. Alrighty, so I've gone ahead and gotten everything buttoned up. Of course, our sheet is on. I've got the side rail covers on as well. Now all that's left to do is get this thing rolled under the car and get it installed. I've already done a couple of videos where I actually show the install process for the pack, so I'm not going to go too into detail with that here. I'm just going to get it in here, and then we'll get the car powered up, make sure that it runs. Alrighty, the pack is back in the car. Now there are a couple things to button up. Of course, we have to put our rear cover back on. Our little skid plate piece has to go in the front here. Big bolts have to go through the subframe. But what I'm going to do first here is I'm actually going to go ahead and get the car powered back up, make sure everything's functional again. We'll probably have to clear the F107 fault, which is that open voltage sense lead. And yeah, we'll make sure everything's working here the way that it's supposed to. And then we'll get this thing buttoned up, take it for a test drive. Alrighty, we'll go ahead and get our high voltage disconnect in, which just slots in like so, and we'll just push that little tab together to lock that guy into place. And I haven't checked to make sure this 12 volt is still holding a charge. It might or might not be. Sounds like it did though, it kind of sparked. Might have to get the power supply on it before we really try to power up the car, because it won't actually power up until we clear the fault. So let me get my power supply and then we'll try and hop in here. Alrighty, got the power supply all hooked up. We'll go ahead and hop in the car here and see what we get. So we are, of course, still in service mode. Let's see. Yeah, we're gonna have to get toolbox here because we cannot do these procedures on MCU1, which this car is equipped with. So let me grab my laptop, we'll get connected to toolbox, and then we'll go ahead and clear that F107 fault, which should be here under the service alerts. It's a latched code, so it's not something that will clear itself. Yeah, see, we've got that 107, so we'll go ahead and get that cleared, and then we'll see where we're at. Alrighty, my laptop's almost dead here, so hopefully it stays alive long enough to actually get this done, but we're currently connecting. MCU1 is always a bit of a pain. It has to unlock the ODIN, and it doesn't always go through on the first try, so we'll let it sit here and do its thing. I'll come back to you guys once we're actually connected. Would you look at that, we're connected. It's just fetching tasks, which should only take a second. But the part that takes the longest is that CKETH unlock, trying to get through that ODIN blocked thing. There we go, now we're done. So now what we can do is we can go over here to Actions, and we want to go BMS, BMS. And we probably want to do a couple things here. But first we want to clear our open VSH latch. I do already have the gateway unlocked, so go ahead and hit run there. Passed. Okay. And then what else do I need to do here? I believe I also need to clear, yeah, SOC, well, I don't know if it's the SOC1 snapshot. SOC1 snapshot, reset CAC, reset SOC. A couple different things here. Because it has an SOC imbalance, because it thought there was an imbalance due to the open VSH. So maybe I will do that SOC1. None of these can hurt, really. We'll go ahead and run that too. Okay. I'm still seeing an F107 fault, which is not a good sign here. Let me grab my other dongle. We'll plug in with Scan My Tesla and see what I get for cell voltages. Alright, well how about that? I was literally just pulling up Scan My Tesla and then the car closed the contactors. So it appears that we're good. I do still need to clear that SOC imbalance, which I did try clearing the SOC1 snapshot. That didn't do it. We can try brick 6 substitution. I don't think that's gonna do it, but we can give it a shot. Alright, I'll come back to you guys when this procedure finishes. Alright, I was actually just reading the stuff on these, and I don't think we actually can clear these because these are not latched faults. They should self-clear on their own once the pack is within balance, and it probably takes some amount of time. As you can see, our pack is pretty well in balance. We're only 10 millivolts out total across the whole pack. So, I think without further ado, well, I guess what I can do here, I'll go ahead and put the car in a drive and make sure we get movement. It did move before it applied the parking brake automatically because the door's open and the front's open and everything. But we do get drive apparently. So all that's left to do is to go ahead and get everything buttoned up, and then I can take this thing for a test drive. Just out of curiosity, if I exit service mode, I don't think it'll show. Oh, maybe. Will it show any present alerts? Yeah, so it doesn't show that as an alert. All we have is coolant low, park assist unavailable, which is because our front bumper piece is removed, so it's missing some of the parking sensors. Yeah, all right, let's get this thing buttoned up. Alrighty, I've got the car all buttoned up, put the bottom covers and stuff back on. I was just doing a coolant air purge. Thought I'd check the alerts again, and that that capacity imbalance or SOC imbalance message went away on its own. So yeah, it just needed a few minutes to kind of recalibrate itself. I've got another car getting picked up from a customer, so we're just going to go ahead and wait for them to head out, and then we'll take this thing on a little test drive, make sure everything's good. I'll also make sure to plug it into a supercharger, make sure it charges properly. A pretty common mistake that can be made when installing the packs on these is if the rapid mates aren't fully seated, it can actually cause issues where the car won't supercharge. And oftentimes everything else will operate totally normally, but if that high voltage rapid mate isn't fully seated, the car won't supercharge. And a lot of people get really thrown off by that when it doesn't really throw any alerts or anything that would tell you what's wrong. It just won't supercharge, and usually it's that high voltage rapid mate that's not fully seated. So anyway, yeah, we'll want to test it, make sure it supercharges, and ensure that the rapid mate is all the way in there. I did, of course, check it when I actually installed it, but we'll just want to make sure the car supercharges and everything. And yeah, and then we should be good to go. Alrighty, we're getting out on the road here. Take the car for just a short little test drive, make sure everything's good. I'll probably wait to actually supercharge it until I actually let the customer know it's back together. Usually I like to let them know if I'm going to supercharge it, because I don't know if this one has free supercharging or not. I assume it does, but I'll just double check with the customer. But yeah, I think we're all good. Car's driving fine. Just take it around the block here and bring it back to the shop. Alrighty, we just got plugged into the supercharger here. We'll just make sure the car charges like it's supposed to, and it looks like it is. It's ramping up in power. We're not going to hit super high peaks or anything on this old 85 pack, especially with it not being preconditioned. Yeah, 40 kilowatts at 50%. That's about what I would expect to see for an unpreconditioned 85 pack at this SOC. But yeah, looks like we're charging. I'll let it sit here and charge for just a couple minutes, make sure there's no anomalies, and then we'll head back to the shop and get this thing all wrapped up. Alrighty folks, well that's going to be a wrap for the repairs on this car here. Yeah, it's really just kind of a tedious, time-intensive process to pull the pack apart, pull the modules out, and just go through and inspect everything real closely and make sure there's no issues. It's not that it's something that's that difficult to do. It's just you got to go through all the steps and make sure to get everything right. Of course, for one, it's really important to pull out every module and inspect all of them. I think a lot of people that try and do DIY pack repairs for the first time, you know, they'll open up the pack, they'll have determined where the problem is, and they'll just pull out the one module that they know that's affected. They'll repair that one, throw it all back together, and then in a couple weeks or months or maybe a year down the road, they're back in the same boat again with alerts again because they didn't go through and check all of the possible impending failure points. As we saw with this one, we had that one sense lead that had become disconnected, but we had, I think it was 5 BMBs that had signs of corrosion that would have been an impending failure point, probably in the months or year to come. Yeah, I actually have another Model S here that's going to be also undergoing some pack repairs. It's actually a P100D, and the only reason it's not under warranty is because it's a salvage title. It's got a very similar failure mode to this, but those actually use a different type of sense lead attachment method. I probably won't do a whole in-depth detailed video on that one like I did with this, but I might just do something short just to kind of show the difference in the failure mode. Basically on those, rather than having wires that are actually ultrasonically bonded to the collector plates, they use wire bonds for the voltage sense leads. And the wire bonds, particularly on brick 3 within the modules, are very susceptible to separation. So anyway, that's the issue on that one, and I'll be pulling that apart here very soon. But yeah, any questions or comments, make sure to leave them down below. And yeah, as always, thanks for watching.